Okay, it's working now. So today we'll be learning collections module. Okay, up until this point we have learned sets, okay, list, array, okay, and we also have some knowledge on tuples and dictionary. Okay, these are our, we call them built-in data types. Okay, these are our built-in data types. Now what we are going to learn are special data types designed uh, for uh, with slight variation. Okay, with slight variation in the functionality of these special data types exist. Now they exist in something called collections module. Okay, so don't worry about what it is. Collections means, you know, a data type that collects items, right? So any data type that collects items, like all of these, all these collect items, right? So this collects unique items. This collects everything basically. This also collects items, and then this collects immutable items. Again, dictionary collects items in key value pairs. So all these are collection types. So hence the name is additional. They have named it as collections module. Now in this collections module, to access that collection modules, I have to do import collections. Okay, so that's it. Very simple. So if I do a dir of collections, I have a lot of options here. If you notice, some of them are listed here. Okay, abc is just a variable I added, don't worry about it. But rest of them, if you notice, these are our collections types. Okay, so out of these collections types, we will see each one by one what these are. Okay, let's have a look at what each one does. So the first one is, I will start with the collect counter. Okay, counter is very easy. Okay, it's just that you need to pay attention and understand a little bit. Now counter, see, let's just say I have a list. Okay, some list I have that includes, it's a list of names. Let's just say you have short name. Let's just say you have um, another person of Faris, then you have other person Sadiq. Okay, then again you have Swapnil. Okay, then you have again you have Yasin. Okay, then again you have Sadiq. Okay, now I want to know how many times each item is repeated. Okay, how many times each item is repeated. Now when I do that, unfortunately I'll have to write a different complex logic to get that count. To get the same count, I'll have to write a complex logic. So very easy thing, what they have done is, they have introduced this counter. Counter is nothing but, let me initialize a counter, collections dot counter. Okay, I have let me import like this. Okay, instead of collections I will type from collections import. Okay, star, I will import everything. Now when I do that, I can directly type the name of the counter that I want. Okay, fine. Count. Why is counter missing? 1 second, I'll have to check. Okay, maybe because, yeah, it starts with capital letter. Okay, usually they name the types with small letters, but for collection modules you remember that, if you notice, it is capital C, capital C, capital O, everything is capital basically, except for this default D, D, DQ name tuple. I don't know why they do this, but they have, maybe they introduced this long back. These came first, that's why they were in small letters. Now these came later, maybe that's why they are in capitals. Anyway, just remember it has to be a capital letter for counter. Okay, when I type counter of some list, okay, some list is not defined, and if I type what is my print, you see what happened. Swapnil is repeated 2 times, Sadiq is repeated 2 times, Mufaris is repeated 1 time, and Yasin is repeated 1 time. See how easy it is, right? So if you want to count how many elements are available and how many times they are available, you can use counter. Another example I'll give you. Let's just say,
So
uh,
background, it will work as a dictionary, key as key
yes,
and value.
yes, correct, correct. So let's just say I want to type counter. Another example I'm just giving. Let's just say, I don't know, happy birthday. Okay, you can take whatever example. See what happened. If you apply a counter over a iterable, so this has to be a iterable, okay, either list or string or even a paragraph, or even a dictionary. So that also I will show you. So what it is doing is it is counting how many times a is repeated, how many times p is repeated, so you get the count. Okay, let's look at another counter example. Counter of, let's just say I have, let me see if I have something called para. I'm not sure if, okay, not defined. So let's just say para equals to some paragraph I'm defining. Okay, hello, how are you today? Did you attend the classes? Something like this. Okay. So if I type this para, see what happened? It counted at letter level, but that I don't want that. I want at word level. So I will split it. If we remember from string methods, if I apply split, it will split the sentence into words. Okay, instead of reading at character level, it will now read at word level. So this is how you get, u is repeated 2 times, rest of the things are repeated. Okay, and one more example I will show you for dictionary. Let's just say you have counter of, okay, so you have something like, okay, I will take simple example. A is to 4. Okay, then you have B is to 2. Then you have C is to 3. Okay, what happened? You got the same dictionary back. Okay, so but if I had another value, let's just say, no, actually keys are unique, right? So you can't have, but I will still try to add um, another value based on, okay, yeah, so keys are unique, that's why it's can't, for dictionary it will return the dictionary, that's all, that is what I'm trying to say. Okay, for a dictionary it can't count based on keys because keys themselves are very unique. So you can't have two same uniques, you can't have two same keys in a dictionary. That is why when you apply a counter on a dictionary, you will get dictionary back. Same thing. If you apply on a set, let's just say you have a set. First of all, you are you can add repeated items in a set. Okay, that we have already known. But when you do a set thing, okay, that itself saves the elements as unique elements, and when it saves elements as unique elements, see what is the answer you are getting. Even though I have provided one as how many times, one, two, three times I have provided, but what is it saying? One is available one time, two is available one time, three is available one time, because simply because set itself stores unique elements. You understand me? That's why your result will always be 1 1 comma 1 comma 1. This is 1, this is also 1, this is also 1. Is this clear?
Yes, Sadiq. Sadiq, can you explain dictionary once again?
Sure, sure. See, dictionary is very simple. If you pass a dictionary to a counter, you will get dictionary back. Why? Simply because all the keys that we have here, A, B, C, D, they can't be same. Okay. For example, if I repeat some value here, instead of D, if I add A, okay, see what happened. A value is, A was supposed to be 4. Okay. First, when this counter started counting a value, it started with 4 only. Okay. But then it went to calculate. First it had A is to 4, then it had B is to 2, then it had C is to 3. But again, because it encountered A value, it replaced old value with new value. That's why you have 3 here. So the point here is, keys are unique. And because keys are unique, you can't have counter of those values. If you apply a dictionary, if you apply a counter to a dictionary where you have repeated key values, dictionary itself will replace those value first of all, even before counter can count them. Okay, that also I will show you. Let me take this as an example. Okay, see, this is a dictionary. I'm not applying counter. You see what happened? First A value was 4 only. When dictionary started assigning these values, A was 4, B was 2, C was 3. But because it re-encountered A again, it replaced that 4 value with 3. Dictionary itself did this even before counter can count the values. So that's why I said counter of a dictionary will always be a dictionary only. So dictionary itself was, even though we provided this is what was passed to the counter and this is what has been retained by the counter. Same thing applies to set also. Okay, if you have this set, okay, let me take the set again. If you have this set, even though you are providing repeated elements, set itself will filter those elements out and keep the unique elements. And when these unique elements are passed to the counter, it will return the set only, set count only. Okay, so you always, the count will be 1 only. Is this clear?
Yes, Sadiq.
Okay, all right. So next one, counter is done. Easy. Okay, but I would recommend that you practice. Sorry. Okay, the next thing. So we have something called default dict. Okay. Now dictionary we know. We know dictionary. I'll take this example only. Dictionary we know. This is some dictionary. Okay. Some dict equals to this. And if I print some date, so fourth value will be replaced and I'll have this one, this value only. Okay. This value is getting deleted. This value is getting assigned. So that's why you have E equals to 3 here. Now see the order of the elements. See order of these keys that you have. So here you are getting in order. Okay. Sorry, what default dict? Okay. Default dict. I think I got confused. Okay. Anyway, fine. So default dict. So this is your dictionary, right? Now the disadvantage of this dictionary is, if I want to add something to this dictionary without mentioning a particular key. Okay, for example, I want to add some dict of D value. Okay, here I will mention D. Okay, okay, fine. So what happened? You got error because stating that key does not exist. Okay, so key cannot be added without value. But had I provided this equals to 4, it would have worked. Okay, it would have worked if I provide with a value, but without a value if I do, I'll get a key error. Now to mitigate this problem, we have something called default dict. Now the way default dict works is, I will type the same thing. I will type sum underscore dict 1, okay, equals to, I will provide the same values, default dict of same values, okay, and then I'll print sum dict of 1. Arguments are not callable. Okay, fine. Okay, fine. 1 second. No. Okay, so you'll have to provide without arguments to produce a new value. Okay, get items. Okay, fine. So here you will have to specify uh, some dict of, okay, I will not pass the dictionary. First I will define what it is. Okay, let's just say I will define it as, okay, string. What I'm doing is I'm initializing this variable as a default dictionary where I'm going to store string values. Okay, when I do that, now I can start to add values to this dict, and first value would be a, which is what we had, right? A is equal to 3, and then I will add some dict of 1 of b, okay, equals to 2. So now if I print some dict, I have this default dict which is same as your dictionary, but here is the difference. Sum underscore dict 1 of, now I will add a value, but I will add a key, I will not add a value. See, this is what I'm trying to do. Okay, the same
Okay,
thing.
Sadik, here,
Hmm,
instead of list A is equal to 3,
hmm.
right? We can assign in dictionary A 3 and B 2 with the flower bracket.
Where? Here? Okay,
Some underscore dict. Yeah.
sure,
Instead
sure.
of list, you have given list, right? A
Hmm,
and B list you have given, right?
hmm.
So
Okay,
instead of that square bracket,
uh-huh. So you're saying
uh,
assign like this.
yes,
So here if you assign E is to, let's just say 5, comma, F is to 6, that operation itself is not supported. Okay, so see here it is, see this is the confusion. The confusion is every time you see a square bracket, it's not a list. Okay, so list is when you have uh, something like this but with a square bracket, that is list. Okay, this is not a list, this is rather accessing the index. You remember indexing and slicing that we did, where we
yes,
passed
yes,
one
yes.
value. So this is the index. Basically when you assign some dict 1 of a equals to 3, what we are saying is create a variable called a and assign a value called 3 inside this dictionary. That's what it means. Okay, it's not a list, it's rather a key value pair. This is a key, this is a value. Okay, that you'll have to remember. So this won't work. This is not even a supported operation. Okay, I will leave it as is just for your remembrance. Okay, so if you notice, I was saying for a dictionary, normal dictionary, it returned a key error. Okay, but for a default dictionary, if I pass that same value, same way, if I'm passing E, there it's failing. Here I'm passing C. Now what it is doing is if I don't pass a value, because I had defined it as a string, it is adding empty string, okay, and assigning it to C. So no more key errors. You won't get key errors when you do like this. Instead, it will add a empty string. Now what if I define my default dictionary without string? I define something with some other thing instead of string. Okay, I will
Integer.
define, yeah, integer. I will define integer, but I will assign it to something like int dictionary, just so that I can have better naming. Okay, now my int dictionary int dict, if I add a value to it, let's just say I want to add a value as uh, something I will add. Okay, a is to 1, b is to 2. Okay, okay, actually this won't work. We have to add
Lower
like this
bracket we
only.
are adding.
Yeah, yeah,
Okay.
we have to add like this only. Okay, this is okay. Now if I check int dict, this is a default dictionary with int initialization, and you have as 1. But now what I'll do is I will try to add b, but I won't provide any number to it. See what happened? What happened was, okay, I will remove this. Okay, what happened was, because I defined the default dictionary as integer type, it is replacing the empty values. I mean, wherever I don't provide values, it is adding 0, a number. Here it is adding empty string. If you pay attention and recall, these are all false values that we saw previously. 0 is a false value, empty string is a false value, empty list is a false value. Okay, so that way. Now let me try another thing. Now this time I will try with float. Let's see what it adds. Okay, so here I will say float dict flo. Okay, dict of, I will pass float. Now this time if I try to add flo dict of, for a value, I'm I'm just adding equals to 4. It should, let's see, ideally it worked, but ideally you should have provided a float value because you have defined it as float. Okay, now I will provide b. Now see what happened. B took it. Let's see what is present inside this float dict. See what happened. It accepted the number. Okay, ideally it should have been 4.0, but there is something called type conversion in Python, so it will accept float. If you have defined it as float, it will accept int also. Okay, so don't worry about it. But if you don't provide the value, this is what we are interested in, it will automatically add 0.0 because it's a float default dict. What other types can we try? We have tried with string, int, float, and you also have um, complex type, but you'll have to import math module for that. Import math, and then you have math dot complex. You don't have complex, is it? Okay. How about cmath? Import cmath dot. Okay, first import cmath, and then you have cmath dot. No. Okay, what about math only? Math and dot math dot complex. Okay, even complex, okay, is not there. Okay, but what if I directly type complex of 1 comma 2, Okay, okay, fine. Complex is working directly. So this time what I will do is, you know the complex numbers, right? You have real part and imaginary part for complex numbers. Now this time I will define the dictionary as complex type. Okay, so here I will type comp of complex, comp underscore dic. You see, it worked. Now to add a value, we will do the same thing. Instead I will, here I will add a value as 6. You see what happened? Now if you visualize complex dictionary, it has added a value as 6. Okay, I will add another element without defining the value. Okay, it added the imaginary part, and if I type complex date, you see what happened? This is your default dictionary. So when you add a number, when you add a number by yourself, by passing a value, it will accept that as a real value. But when you don't define a value, it is accepting, it is automatically adding that value as a imaginary value, zero imaginary value. Is this clear? Is default dictionaries understood?
Yes.
Yes, yes, Rajesh.
Default dictionary is a special dictionary they had to come up with to certain, to rectify certain limitations of dictionaries. So these are also your data types only, just the modified versions of your data types. So if counter is clear, default dictionary is clear, then we can move on to the next one. Okay, so default dictionary is done. Then we have ordered dict. Okay, very similar. Okay, very similar, but there is a minor difference. Now if I define something as, let's just say odd underscore date equals to, I will define it as ordered dict. First I have to define it, okay, as ordered dict, and then once I initialize that, then I will start adding the elements. The way how I add elements is exactly the same. Let's just say 7 equals to 7 I will add. Okay, and then I will add uh, odd dict of, I'll add another element. I will add another element as 4. Okay, 4 equals to 4. Hmm. So we have defined this as ordered. Now if I print ordered, I have 7 comma 4. This you can see directly. Now what is to be noted is, you compare this with default dict, okay, and ordered dict result. Try to compare. What are you getting? Here you are getting the elements. You can access the elements directly. For example, if I had typed comp dict of, I want to access the file what is present in the B, I would have obtained this OJ. Okay, so that means the you are directly able to access the keys here, but here the keys and values are provided to you as a tuple. Here if I want to type the same thing, ordered dict of, let's just say 7. Okay, so I'll get the 7 part. Okay, here also is the same only, but the result differs. Result you are able to get it as list of tuples. Okay, if you notice the difference here, this is one difference. Second thing is, let's just say, now I'm showing the difference, actual difference. Okay, let's just say I want to add another element which starts with a. A P apple equals to, I want to assign it to 5. Okay, now if I print, okay, you got the result. If you see it in a one go, you won't understand what the difference is, but there is difference. Here I will add another element. Okay, let's just say
So this is working as an append.
no, this is working as append, but I want to show you the actual result, actual difference. One second. Comp dict of, let's just say I want to add, first I will add e. Okay, e is equal to 9 I will add, and then I will add comp dict of, then I will add d. Okay, then I will assign it to 4, then I will add comp dict of c is equal to some value, it doesn't matter what value is. Then I will print my comp dict. You notice something, the way how it is working. So if you add this a and okay, let me retype. Okay, so here if you want to insert com dict of okay, update of um, let's just say c is to 6. Okay, all right. So let me try this for normally for a dictionary. There is a difference. Okay, I'm trying to. All right. So ordered dict. Okay. The main use of ordered dict is if you want to have elements in certain order. Here I can manipulate the order by, if I try to access elements and reappend, I will get the different order. But here you can't modify that order. Once you add in this order, first you added 7, so 7 will always be the first element. There is no way to go back. If you add 4, then 4 will be the next element. Then if you add apple, apple will be the next element. Okay, so the order is maintained, order of keys is maintained. It won't allow you, okay, to change the order. So if you iterate, let's just say if I iterate over this one in our normal dictionary, d dot keys I can access, and although it is showing as different, but you can still have, I think, let's just say if I modify, how do I modify without uh, changing it? Okay, fine. For e in d dot dicts, okay, uh, 10 key. Okay, it's coming in same order only. But anyway, so although it is not coming up here, okay, but for ordered dict, once you define it as the ordered dict, okay, the order is written. You can't modify the order. See?
So we can't sort it. We can give sort and we cannot do it.
Yeah, sort method is not available for dictionaries, but let me check if I can sort it. Okay, order dict dot get visa items visa. Just move any function. Okay, and what is this d dot? There is no sort method. There is only Okay, there is no sort method, but let me see if I can write a custom uh, code. What we can do is, so we'll have to, let's just say this is the dictionary, but then you'll have to delete the dictionary and recreate it. Anyway, anyway, don't worry about it. Okay, so just for now, just remember that ordered dictionary is a special implementation of dictionary wherein the order of insertion is remembered. You can't modify this order. Okay, so it will always remain like first element, then comes like 4, then comes apple. Okay, if I try to make a change, it won't allow me. That I will do one thing, I will show it in the next session. Okay, but for now just remember ordered dictionary will remember the order in which you add the elements. There is no way to modify those. Okay, or I can do one thing, why not try updating the same element. Okay, let's see. Okay, it will allow me to update. Updation is fine, I think, but the order it will remain as is. um, okay, one thing I can try. This is kind of little tricky. Let's just say I will deliberately modify a normal dictionary, just like how we did, but this time I will assign it as value as 12. Now I will check the dictionary. Interesting. Okay. So it has the same kind of behavior. Okay. Okay, no worries. So just remember order dictionary. The order cannot be changed. Order of keys. Okay. Order of keys cannot be changed. So that you remember for now. I will see how it is different. How is a ordered dictionary different from a normal dictionary? That I will check and let you know. Okay.
Can we change the positions?
That is what I'm trying to check. If we can try to change the positions. Um, I will see and let you know. Okay. Um, okay, fine, fine. Don't worry about it for now. Okay, don't worry about this. I will come back to it after the breakfast break. But up until this, are you following me? Up until at least this default, did you understand?
Yes.
Okay, okay,
Yes,
all
Adi.
right,
Yes.
all right, no worries. Okay, so we'll move on. Okay, the next thing is very interesting. It's called named tuple. Okay, named tuple. Okay, what named tuple means, you already know the normal tuple, right? So let's just say you have a person, and where you have something defined as a tuple, where you have something called uh, age, then you have something defined as height, then you have something defined as name. Okay, so and if you type a person again, you get a person. All right, but here is the thing, if you want to have these values assigned to particular person, let's just say I will say a person by name David equals to, let's just say he had an age of 30, height of 170 centimeters. Okay, uh, and name as David only. He's person 1. Okay, if I print the David, you will get those values. But if I want to have the same values assigned to a different person, okay, I want to have in a very similar fashion. Okay, in a very similar fashion, I want to have another person by name John is equal to these values where you have this John. Okay, I will assign this as 30. Then you will have a John. Okay. Now what is happening is, if I want to have different values of tuple assigned to different people, this will work. This is fine. There is no implementation issues here. But what if I wanted to have these values under same name? Let's just say, what I'm trying to say is, I want to define a person, okay, in such a way that this person, for one person these values hold like this, for second person also they hold like this. So I want to have something, some mechanism where different sets of values get assigned to the person. Now if I try to print this person, only the second time whatever the values were there, only they are retained. First time when I try to assign, these values are lost. You are following me now? If I wanted to have one common person and have a values assigned under those person, values of various names or different values assigned to same variable, I can't do that with the tuple. The second time that I assign, only they are retained. First time whatever I assigned, they are lost. Okay, this problem is solved using a named tuple. For that, what I'm gonna do is, I will redefine the same person, okay, as a named tuple. If you type named, you will get named tuple. Now here what I will be defining is, first I will be defining um, what sort of values I'm going to store. Okay, I will define it as, notice how I am defining the value as a string and putting everything inside a list. I'm defining age, and then I'm defining height, 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 and then I am also defining the name. This is what I wanted. So now I have defined this person. Okay, let me put as a capital P just to have difference between that person and this person. So this person I have defined. If I print this person again, this is my main class of the person. This is how it has defined. This is no longer a tuple. Instead, what it has done is, it has taken this entire tuple and made it as a some sort of class. Okay, and to that class we will be adding the values. So if I call, okay, let Dave be one person, or David be some one person, and you pass this person value, okay, and to this person you are going to pass slight different implementation, okay, and let these values be assigned to John. John equals to, but I'm calling, see how I'm using the same person value here, person of um, person of John. Okay, now if I want to check what do I have, okay, inside this each one of these people, I can simply type David. I'll get David belongs to a class called person, which we had defined. I mean, not even a class. It's a named tuple. Sorry, it's not a class. It's a named tuple. So David belongs to a named tuple called person, which can store which has these attributes. And likewise, if I define John, and John is also a person who happens to have different attributes. Now like this I can have multiple attributes and all will be listed, tagged under a common tagging called person. Basically the difference between this implementation, this implementation, and this implementation is, here you are directly assigning the values to different variables. You can still access those attributes using various variable names, but you don't have any tag value assigned here. Today David could be the name of a person here. Tomorrow David could be the name of a person of a company, David Industries. someone can come up with that, right? Or david.com, it could be a website. How do you know whether these David variables, this David who is a person is different from David who is a company, right? To sort out that issue, they have added something called a name, a tag value, and we call, so that's why this named tuple is doing. It's simply adding to this variable. It is simply adding an additional tag. Okay, this could be a person, and tomorrow I can similarly have the same David. Okay, I'm defining this. Now I'll be defining this as a industry. Okay, here I will call it as industry. Okay, this could be different. This could be whatever you see here could be different. So again I will define David only. David is now not a person but rather a industry. With I mean, for the sake of the argument, I'm just passing the same values. But if you notice the difference between David, who is a dictionary, sorry, who is a industry, and David, who is a person, you see, you can just basically named tuple is allowing you to add an additional tag to that tuple. Now this will indicate this is industry and not person. Is this clear?
Yes, Sandeep.
Yeah.
Yes, yes,
Con
Sadiq.
yeah, concept I think you have already understood. It is same as adding some tag, but remember the syntax. You just have to call it as a named tuple and pass some value here, and whatever the value you pass here will be assigned to this named tuple, and inside that you can pass the values. Okay, instead of the minor changes, instead of passing it directly as a tuple, you can pass a tag, pass the values, and call it a named tuple. Basically that's the difference. Just add a tag, pass the values, call it a named tuple instead of a normal tuple. Okay, that is the difference. Okay, this is another collections type. Okay, I think we can stop till here. It's already 9. Anyway, our meeting will also end. Okay, so I will stop the recording here.